Hello, ma'am.
Hello, Nalin.
Yes, ma'am. Ma'am, can I share this on the WhatsApp group?
Yeah, can you share, because I don't have contact with students?
Yes, ma'am. I'll share it.
So you could get in through the link that I sent, right?
Yes, ma'am.
Yeah, okay. Then please do that. I'm also contacting the 7th sem students because this is
Yes, ma'am.
common to both. Okay.
Yes,
Yeah,
ma'am.
thank you. Good afternoon, all of you. I'll just wait for another maybe 5 minutes for people to join in, and then we'll start the class because of the delay in getting the links. Hope you're able to see me and hear me. You can
Yes, ma'am.
Yes, ma'am. We can.
Okay, thank you.
class?
Yes, sir. 150. Just So good afternoon, everybody, and I welcome you to the course on speech processing. What I'll do now is I'll quickly give you an overview of this whole course, and Can somebody confirm if you are able to, if I'm audible and everything is okay?
Yes, ma'am.
Yes,
Yeah,
ma'am, you're
all
audible.
of you can keep your audio off. I'm not muting all of you because the number is not very large. Assuming that whenever there is a query or any kind of question, you can always unmute and ask the question. Otherwise, kindly keep yourself muted. And if everything is okay, then we'll start with the class, right? So what I would, yeah. So what I'll do is we'll have a quick introduction to the course. We'll see an overview of the entire course and how we are going to go about the evaluations in this course. And after that, I'll take you through some basic review kind of thing on making you remember or realize or recollect whatever you already have studied in the basic signal processing course. So I'll take you through a quick summary of the whole course through in the form of a video. Please have a look at this, and then we will continue with the review of the basic concepts needed to understand this particular course. I welcome you once again to this wonderful course on speech processing. I promise you that you are really going to enjoy the course because it's a very, very practical course, and kind of hands-on experience on this will make your concepts in signal processing very strong. And those who aspire to kind of gain expertise or study further in the domain of signal processing, this is going to be a kind of I would say strengthening the foundations of signal processing, so that you don't face any difficulty when you either go for higher studies or you take up a job. And if you're fortunate enough and if you get to work in the domain of speech, audio, music, be it or image, be it any kind of signal processing, the foundation laid is definitely very helpful. So I think kindly mute your volume as somebody is, otherwise I'll have to forcibly mute it. Just give me a second. Yes, so I welcome you once again, and let's start with this short video which will take you through the entire course. Sorry for the delay.
Hello everybody, I am Shikha Tripathi from the Department of Electronics and Communication Engineering, and I welcome you to PES University Online. I'll be taking you through the course on speech processing. This particular course is to be done by students who have gone through the basic course in signal processing, because this is a specialized course in the broad area of signal processing. The courses which one must have gone through before taking up this specialized course is Signals and Systems and Digital Signal Processing. Now, while doing those two courses at undergrad level, I'm sure you would have wondered why exactly you're doing all that mathematics, why exactly you're solving so many problems, where are you going to apply all that, and so on. Here is the answer to all those questions, because this is a course which is a direct application of whatever you studied in those two basic courses. You'll really appreciate the course better if your foundation in those two courses are really strong and you enjoy doing those two courses. This will really be a very useful application kind of course, which will expose you to various domains or applications where a study of speech processing can be applied to. In this particular session, I'll be taking you through the introduction to the course and give you a brief overview of the course to give you an idea about what all is in store for you as you go along in this particular course.
Can I get a feedback if the audio of the video was audible and the video was okay, so that I can continue further? Hello, can anybody? Yes, can somebody say if the video and audio was clear?
Yes, ma'am. It was okay.
We'll continue with that. Thank you so much. Yeah, no, I'll not interrupt now. We'll go ahead. I just wanted to check. Thanks a lot.
Now, whatever I spoke till now seemed to be very effortless, isn't it? I just had to have some kind of basic idea in the mind as to what I'm going to talk, sequence those thoughts, and just start talking. It seemed to be really very effortless, and that's how natural it is. But then when you think of the whole process that goes on, starting from the thought to the speech that comes out, we all have understood in biology or studied in our basic biology in school how we produce sound, or what that entire physiological system is made up of. And we also studied how exactly we listen to whatever somebody is talking. Whatever information the medical fraternity or the medical community has given to us to understand what exactly goes on inside us when we try to talk or when we try to listen was comprehended by the scientific community, understood properly, and then the scientific community tried to mimic whatever happens naturally within us when we talk and when we hear. So taking clue from that, Flanagan in 1975 with his team at Bell Labs MIT developed a mechanical system which could mimic the way we talk. It was a huge system which was designed just to understand the whole process, and it was a very laborious task and a very difficult exercise, indicating that things are not so easy or not so effortless. We need to put in a lot of effort if we want to look at it from an engineering perspective. And that's what we try to do in this particular course. We as an engineer, we try to understand how we talk, how we listen, and then try to find out some kind of mathematical model, or try to give an engineer's perspective to it, so that we can build some applications which could be useful to society at large, and we could do something more meaningful with the signal that comes out from us so easily. So looking at this whole broad domain of signal processing, what all we as signal processing engineers actually do, or what all are the various modules which we generally go through. If you look at it, initially the first thing that comes here is the source itself. So you have an information source, and then that is followed by a measurement or observation. And then we try to represent the signal in some way which we can mathematically understand. And then we try to do some kind of transformation if required, so that we can see the signal in a different perspective, in a different manner, and make something useful out of it. And that's what results into the extraction and utilization visualization of the information that we have generated from the source that is available to us. Now, this is the two modules where actually the signal processing fraternity works would be the signal representation and the signal transformation. This is generally the depth to which, or these are the modules where we try to contribute something. Now, if I try to connect this to the study of speech processing, then these are the various modules that you will see in speech processing. The first one being the measurement of the acoustic waveform. First of all, I need to have a device to measure the speech or the music or the audio signal that we want to process. And then we try to represent it using some kind of model. We call it as speech production model, or we have another way called as waveform and spectral representation. And having done this, we try to make use of that to analyze or synthesize the speech that we have modeled. And once we have done that, we can move on to the next block, which is called as the transformation block, where we try to modify it to whichever suitable form that we want to, depending on the application that we are targeting. Now, if I want to connect this entire speech processing steps or the procedure that I showed you just now, you can easily connect it to the basic signal processing steps as well. The first one being the measurement or observation, and that is the first block of speech processing, which is measurement of acoustic waveform. And then we do signal representation, and these are the two ways in which I can represent any given speech signal. And then you have signal transformation, which again is there in our speech processing block diagram as well. And then extracting the information and utilizing of information is what we do when we develop various applications from whatever mathematical manipulation that we have done. We could be doing some kind of modification, we could be doing coding, we could be doing speech and language recognition, we could be doing speaker recognition, we could be doing speech enhancement. Name it, and you have multiple applications that can emerge from the last module that you see in the entire speech processing structure. So broadly, these are all the modules that we come across when we get into the study of this area called as speech processing. Now, coming to the course description, just to give you an idea about what is in store for you when you do this course and how exactly we are going to take you through. In one sentence, if I want to put whatever I told you just now, this course deals with modeling and analysis of speech signal, which was our first two blocks, wherein the concepts of DSP techniques are applied to understand various applications involving speech processing. That's all was given in the block diagram that I showed you in the previous slide. Now, this starts with a discussion on how humans produce and perceive speech, to details of computer-based speech processing for diverse applications. So once we have understood how we produce speech, how we perceive speech, we move on to developing some applications which will have immense utility to the society. This course provides a solid background for any advanced studies or projects related to speech processing. So that's what is the description of this particular course. Now, coming to the course objectives, meaning after doing this course, what exactly is expected or what exactly should be the outcome of your entire study? Basically, start with, you will be learning the basics of speech signal processing, analysis, and modeling of speech signals. And then we'll provide an understanding of discrete time speech signal processing techniques that are motivated by speech model building. And then we'll show how signal processing algorithms are driven by both time and frequency domain representation of speech production, as well as by aspects of speech perception. To introduce applications such as speech recognition, speaker recognition, enhancement, etc., would be the final objective of this particular course. And the outcomes that you will expect after having done this course will be able to characterize speech signal in relation to production and hearing of speech by humans. We'll be able to design few algorithms for speech analysis. We'll be able to construct, develop speech recognition, synthesis, and coding. We'll be able to illustrate practical aspects of speech algorithms and its implementation. And finally, through simple projects, we'll be able to design a processing. For example, in speech detector, like when I'm talking, when is it that I'm talking and when is it that I'm silent? I might not be talking for the entire duration. So if I want to detect when or during which period I have actually spoken and when I was silent, I could do that using certain algorithms. And I could do recognition of a limited number of isolated words. Let's say I spoke a whole sentence and I want to isolate the words wherein I used, let's say, and or of or good or bad. I could isolate these words and maybe use it for some kind of application. So any of these simple applications you should be able to develop after having gone through the entire speech processing course. So with that deliverable in mind, I'll take you through the course overview, telling you exactly what all we are going to do in this entire course. The whole course is divided into 5 different modules, as it is in most of the courses at PES University. The first unit deals with digital models for speech signal. The second unit deals with time domain models for speech processing. The third unit deals with frequency domain methods for speech processing. The fourth one is homomorphic speech processing and linear predictive coding. And the fifth unit deals with applications of speech processing. Now you can easily relate all these 5 modules that I've shown you to the basic block diagram that I had shown you in the beginning. All these modules are designed in a manner so that starting from the basics, you should be able to go till at least some simple applications of a speech process. And I'm sure you'll be able to do that after having gone through the entire course. So with that in mind, let's look at the detailed course plan for you. The first unit is made up of 10 hours, approximately 10 hours is what we'll be spending on this particular topic. And here we'll be discussing digital models for speech signals. As I mentioned to you, the first thing that we are going to do after having measured the speech signal is model it. We should be able to represent it using some simple mathematical formulae or expressions so that we can work on it and come up with some engineering manipulations onto those expressions. So the mathematical modeling of the speech signal is something that we need to understand as the first block or first unit of this particular course. And what we are going to do here is we'll understand the process of speech production. Definitely we'll have to revisit the biological or physiological operations that take place when we produce speech. So we will do that quickly, analyze that, because without doing that, we will not be able to appreciate or find a mathematical model to the physiological process. So the process of speech production is very important. And then we'll talk about the acoustic theory of speech, acoustic phonetics, and prosody. Meaning, we'll be talking about the basic theory, what are all the acoustic features that we look for when we want to model a speech? What do we mean by phonetics? How many phonemes exist in English language? What do you mean by prosody? Some people have a musical kind of speech, or some regions have speech which have some kind of melody in it. So how are these prosody features incorporated in the speech signal, or how do we identify the prosody features of the speech signal? Then we talk about speech perception, wherein we'll talk about how we hear and what all goes on into the at the receiver's end. And then finally, we'll model the whole thing into a lossless tube model, and we'll find out the digital model for speech signal. So that is going to be the objective of the first module. The second module deals with time domain models for speech processing, wherein we'll try to find out some mathematical ways or models by which I can represent the speech signal in its raw form as a function of time. So that's the first thing that we will do in the second, or that's the first kind of modeling of the speech signal that we will be doing in the second unit. So what all are we going to focus on here? We'll talk about time-dependent processing of speech. We'll talk about short-time energy and short-time average magnitude. We'll talk about average zero crossing rate, speech versus silence discrimination using energy and zero crossing. We'll talk about pitch period estimation, then short-time autocorrelation function, short-time average magnitude difference function, pitch period estimation, and autocorrelation function. So these are the various things that we'll be studying in this particular unit. The third unit is the biggest unit, wherein we'll be spending a little more time than the remaining units. I've given 14 hours of discussion to this particular unit. And in this unit, we'll be looking at frequency domain methods for speech processing. So we did time domain in the previous unit, and we'll be talking about frequency domain methods of speech processing. Now, if you go back to your basic course on signals and systems, you were taught there two different domains in which you can look at any signal, the time domain and the frequency domain. You were taught about Fourier transforms, you were taught about discrete Fourier transforms, fast Fourier transforms. We are going to make use of that in modeling the speech signal from the frequency domain perspective. So we'll talk about short time Fourier analysis, wherein we'll look at it in two different ways, called as Fourier transform interpretation and linear filtering interpretation. We'll talk about filter bank summation method. Again, this is something that is familiar to you. We'll talk about overlap add method for STFT. Then we'll talk about design of digital filter banks. In your basic DSP course, you studied about digital filters, you studied about design of digital filters, FIR filters, IAR filters, and we are going to slightly extend that particular knowledge to design of digital filter banks, which is nothing but bank of filters and not just a single filter. So again, that knowledge is going to be very useful in the design of filter banks. And then we'll move on to implementation using fast Fourier transforms. Again, something that's not completely new to you. You have done FFTs in your DSP course. You were taught about decimation in frequency and decimation in time, methods by which you can compute discrete Fourier transforms. We are not going to get into those algorithms. With the understanding that you already know them. We'll just be taking up how do you implement STFT using FFT. So that's going to be the focus for us. And then we'll talk about spectrographic displays. Now, spectrographic displays give us a view of both time and frequency domain representation in one single window. So that's going to be the spectrographic display. We'll try to understand how a spectrographic representation is a three-dimensional representation where you can see the time and frequency and the strength of those parameters in the same graph. And then we'll be talking about pitch detection. Now, pitch detection is an important parameter which we generally come across in the speech processing area. The fourth unit is given 10 hours of time, and this deals with homomorphic speech processing and linear predictive coding. Both these topics are going to be completely new to you. I'm sure you might not have come across these topics in any of the earlier courses that you've done. So it will be an interesting study. We'll talk about homomorphic systems for convolution, wherein we talk about the computational consideration. What is the computational complexity in these homomorphic systems, which we use for convolution. We'll talk about complex Kepstrom of speech, pitch detection, formant estimation. Then again, there is a terminology called as Mel frequency Kepstrel coefficients. You must be hearing two very different words, Kepstrom and Kepstrel. We are familiar with spectrum and spectral, and now I'm talking about Kepstrom and Kepstrel. We'll study more about that when we do this particular topic. It's very interesting. And then we'll talk about homomorphic vocoder. We'll talk about linear predictive coding of speech, a very, very important parameter which is used in many applications of speech processing. So we will give a lot of time or a little detailed discussion on linear predictive coding. What are LPCs? What are LPC coefficients? What is the kind of information that we derive when we get LP coefficients? And then we'll talk about basic principles of LP analysis and solution of LPC equations and talk about prediction error signal. That is the fourth unit. And in the fifth unit, which we are going to spend again a little more time than the other 3 units. We'll be giving some 12 hours to this approximately. We'll talk about the most interesting aspect of this course, which is applications of speech processing, which I'm sure at undergrad level is something that is more of interest than the entire theory itself. Once you appreciate the applications, once you understand the applications, the theory behind or appreciating the applications will take you knowingly or unknowingly to understand the theory behind it and get deeper into what is involved in working on those applications. So with that perspective, I have given a little more time to these applications, and we try to look into some very popular applications of speech processing: speech and format detection, voice response systems, speech enhancement, speaker recognition and verification, hidden Markov models, HMMs. I'm sure you must have come across these, at least the terminology of HMM in some study, if you have done any additional study during your course of BTech program till now. We'll talk about the isolated word recognizer using HMM. We'll talk about automatic speech recognition, ASR using HMM, and then introduction to speech synthesis, the reverse of the whole process of producing speech. Reverse of analyzing speech and processing is your speech synthesis. Can I synthesize? Can I go back, understand the whole system, and produce speech in a synthetic, using some synthetic methods? So these are the various reference books that we will go through, that will be required to understand whatever I have told you till now. And out of these 5 books that are listed here, the first 2 books, the textbook by Raviner and Schaffer, again, these 2 authors are known to the signal processing fraternity and students. You must have studied Raviner and Gold and the DSP textbook, which was by Brokes and then Schaffer. So these are all celebrated authors in the area of signal processing. And the second textbook by Katari is again a very good reference book in speech processing, which you will find very useful to understand certain things little more deeper than probably, or maybe certain topics are more easily explained in the second book than the first book, but your entire syllabus is drawn from the first textbook, and the flow of the topics is directly related to or directly taken from Raviner and Schaffer. So I am sure you will go grab that book, have it with you, not the soft copy, but the hard copy, because reading a book is always a pleasure than reading it on your mobile phone or on your laptops. So please do that if you really want to appreciate and understand things better. So with that, we end this session, and in the next session, I'll take you through some basic terminologies and also take you through this entire speech communication process and the speech communication pathway. Thank you so much.
Yes, just to continue from whatever had the overview that I gave you in the course, the evaluation module, which again I believe is something of interest to all of you. Now that we are not physically with each other going through the courses and taking up the exams, and everything is very, very uncertain, but then hopefully if everything goes fine after about a month or so and you're back on campus, then these would be the modules or evaluation components that I plan for you. Your first test carrying a weightage of 15%, second one carrying a weightage of again 15%. This is the common practice at PES University for most of the courses. And then I have the third component for you, which carries a weightage of 10%, which I call it as project assignment. And this is the unit, or this is the module where we'll be carrying out some simple practical, I would say hands-on sessions on whatever theory that I teach you in the course. So I would divide this project assignment into 2 parts. One part wherein you will be carrying out some simple algorithm development to see for yourself whatever operations that we study in theory and appreciate the understanding or probably understand things better. And in the second module of this project assignment, I'll be giving you some small minor project kind of thing on various applications that I mentioned during the entire description of the course. So the assignments or the projects will be kept very simple, keeping in mind that you may not have too much of time as you have in a normal 6 months project, but then doing these projects will definitely give you a better insight into the whole course. So those 3 modules and finally your ESA with 60% weightage. So these are the various evaluation components that I plan to take up in this particular course. And what I'll do in the next session, now that we are done with the time that was allotted to us, in the next session, I'll do a quick review of some basic signal processing concepts or fundamentals which all of you have gone through. But then it's very likely that everything is not completely fresh and you don't remember everything the way you should be, because you do many courses after doing signal systems and DSP. So I'll take you through quick review of these basic concepts, and then we'll move on to understanding the terminologies involved in speech signal processing, and thereon go on to the first module of this particular course. So that's what we would be doing. So with that, if there are any queries now, I'll be ready to take up those in connection with whatever I've discussed now. You can ask your question. Whenever you're asking the question, please unmute yourself. Otherwise, keep yourself muted. Anybody has any query regarding the whatever I discussed now or anything related to the course as such? And one more thing which I forgot to add in the description of the applications that we were doing is that when we are talking about the applications of speech processing uses a lot of ML. I mean, many of the applications in speech processing use ML techniques these days. So we will be applying machine learning to many of the applications in speech processing. Neural networks is again something that will be applied to the applications in speech processing. So having done these courses, when you take up the applications or take up the projects, you can always study those things and apply it to the application that we are talking about. So all these, I would say the study of ML or ANN or any other techniques that you can apply to speech processing will be directly or indirectly brought into the course so that you are able to apply them when we are talking about the applications in the last module, or when we are doing those applications as projects that I give in the course. So just to throw some light on the previous experience of the students who have done this course in their 7th semester last year. Many of them took up projects in their final year in speech processing or music signal processing or audio processing, and could do a very good job with probably studying the ML and NN part parallelly along with the projects, and they did not face much of a difficulty, and they could really do very high quality work which could directly be published or which could be presented in conferences. So the knowledge, all these domains are very much related. Therefore, there will be some kind of exposure that you will get to those areas as well. If you're doing those electives, then definitely it's going to be an add-on. If you're not doing those electives, even then, it should not create any problem, because you always have a lot of resource available to study anything in addition to what you're studying in this particular course. And that's how the course is going to end and probably take you further from here. Yes, please. Any questions on the course?
Ma'am, is this the same course for the 4th years also, the speech processing?
Yes. The speech processing for the 7th semester and for the 5th semester, the course is the same. Just because this particular batch, it has been brought into 5th semester, it's being handled early. Otherwise, it's the same.
Okay, ma'am. Thank you.
Any other question?
Ma'am, would be like using any coding language such as Python or MATLAB?
Yeah,
So,
yeah. You're open to. I don't specify which platform you're going to use. You can use MATLAB. You can use Python. You can use any of the additional resources that are generally used in speech processing. There's no limitation as to the platform. That's open to you. You can choose any when I give an assignment. It doesn't matter. We have a platform called as Caldi, which is a very specific to speech processing, and that makes job very simple, just like MATLAB. So that way there are plenty of available resources which can be used, and I will not be limiting you to any particular platform.
Ma'am?
Yeah.
Ma'am, is the software aspect, I mean, the coding part of things, is it exclusive to assignments and projects? Is it not part of the syllabus?
It is part of the syllabus. The syllabus is the assignment part is embedded into the syllabus. It doesn't specifically, I mean, in the syllabus, we don't write it that way, but it is taken care of in the evaluations. Every course, especially electives, have the practical component embedded in the course. We don't specify it.
So we will learn the algorithms, not the script itself in a particular language.
No, you will learn the algorithm through teaching, but you will implement those algorithms using the coding languages. The coding will not be taught to you because that is something kind of self-study. By now you should have been introduced to various programming languages, but you can pick it up. I'm sure MATLAB you must be comfortable with, Python you must be comfortable with. So those programming languages, teaching those languages is not within the scope of this course, but then whatever is taught here, you can always use those languages to implement them, which is what is the intention behind having those project assignments. Okay. Is that what you were asking?
Ma'am, I really wanted to ask if in our lab sessions, if that is the case, if we are free to use any language or any...
You're talking about lab session of speech processing?
Yes, ma'am.
Yes, you can use any language. That's what I said. I'm not going to limit you to any language. You can use whatever you're comfortable with. As long as you're able to do the implementation, get the output, it doesn't matter which platform you choose.
Okay, ma'am. Thank you.
Yeah. If there are no more queries, then we'll stop this particular session and see you again tomorrow at the same time. I hope the link will be, yes, please.
Hello, ma'am. I just wanted to know, is natural language processing also part of signal processing domain, ma'am?
Yes, it is part of signal processing domain, definitely. But then it involves a lot of other computer science concepts as well. So it's kind of a domain which is common to both computer science and signal processing fraternity. Just like image processing is done by both, NLP also is done by both, but it probably has less of signal processing and more of other aspects, but then it definitely comes in the domain of signal processing.
Okay, so ma'am, can we take up a project which involves NLP?
Definitely.
Yeah. Thank you, ma'am.
If the objective of that NLP project has in it whatever I'm teaching you in this course, then definitely it's welcome.
Okay, thank you. Thank you.
Yeah. Is that all? So we'll end this session. Thank you so much for attending and having made it, even though there was a little delay. Tomorrow, definitely you'll be getting the link. In case there's any problem, I'll share the link again through the same people who I contacted, and I'll see you tomorrow. Thank you so much.